On what intervals is the function both increasing and concave up? We have y equals to x to the fifth minus 5x. For increasing, decreasing, horizontal, we have to study the first derivative. So let's take the first derivative. So that is y prime equals to the derivative of x to the fifth. That is 5x to the fourth. The derivative of 5x is equals to 5. And then let's fully factor this. So we have to factor out the 5x to the fourth minus 1. And then factor this one more time. So 5, we have x squared minus 1 times x squared plus 1. And then we factor this one more time. X plus 1, x minus 1. The x squared plus 1 cannot be factored. X plus 1. This, we have to set this equals to 0. We have to set this equals to 0. I will tell you why in a minute. And then when you solve this, do we agree that we have x equals to -1 and x equals to 1? All right, when x equals to 1 and -1, the whole thing is equals to 0, right? Draw an interval. All right, so draw an interval. And then cut the interval using these two numbers. So we have -1 and 1. So that breaks down into 3 intervals. Negative infinity to -1, and then from -1 to 1, and then from 1 to positive infinity. And then we will testing the slope. But first of all, I need to pick a number within this interval. Don't pick something hard. Pick something easy. So between -1 and 1, we can pick x equals to 0. This is called test value. The intervals are called test intervals and test values. 1 to infinity, I will just pick 2. This, I will just pick a -2. And then tell me what f of -2 equals to. So f prime of -2, which is right over here, right prime. So you have f prime of -2. All you have to do is you plug in -2 to the function. So which is 5 times -2 square minus 1, and then you have a -2 square plus 1. Something like this, and you can here you test the f prime of 0 and f prime of 2. I need to know whether that is positive or negative. I did the math already. So after you plug in -2 to the first derivative, this is positive, this is negative, and then this is positive. Either you just take my work, or you can try to do the plug-in and then do the arithmetic by yourself. So what does that mean? F prime is positive, that means the function is increasing in this interval. F prime is negative, that means the function is decreasing in this interval. Positive means increasing in this interval. So let's say, imagine this, you have a curve going up and then going down, and then at this point you have a horizontal tangent, and then at this point you have a horizontal tangent. What is the slope of horizontal tangent? The horizontal tangent, the slope is equals to 0, and that's why we have to set the first derivative equals to 0. The purpose is we set the first derivative equals to 0, so that helps me to study the increasing or decreasing pattern, the increasing or decreasing behavior of each interval. So based on this function starts with increasing, so increasing, and then you reach to horizontal tangent, so this is a slope equals to 0, and then decreasing, and then you reach to slope equals to 0, and then increasing again. All right, so that means the interval is increasing in -1, negative infinity to -1, and past 1 to infinity. So we are not done yet. We will have to study the concavity as well. So for concavity, I will use the second derivative. So for concavity, I have to find the second derivative, f double prime or y double prime. So that is based on that. So what's the derivative of this? The derivative of this is equals to negative 20x to the third. That's it. The derivative of -5 is 0. So this is negative 20x to the third. That's it. And then for concavity, you also need to set that equals to 0. And then that tells me x is equals to 0. And then you draw another interval. So this is a 0, and then that breaks it down into 2 intervals. You draw a number line, and then, sorry, let me say this again. You draw a number line, and then put a 0 right in the middle. So the 0 cut number line into two intervals, from negative infinity to 0, from 0 to positive infinity, and then you pick a test value. Don't pick big numbers, pick something small, easy to handle, and then you plug it into f double prime. So f double prime of negative 1, so that is negative 20 times negative 3, not negative 3, negative 1 to the third, and then this f double prime of 1, that is negative 20 times 1 to the third. It turns out that this is negative, this is positive. We have, why do I use a negative 20? Positive 20, positive 20. I'm sure you didn't make this mistake and you already correct my mistakes. Okay, so this is a negative, this is a positive. If I didn't correct that mistake, I just changed the whole game. Okay, what is second derivative negative means? Second derivative negative means the function is concave down within this interval. So concave down, positive means concave up. And then when x is equals to, set that's equals to 0, you have x equals to 0. So this is an inflection point. So this is concave down, concave up. But how do we put these two pieces of work together? So here is how. So let me do the last piece over here. So we have a one for increasing, decreasing, right? So this is from negative 1, 1. Okay. So this is negative infinity. I don't think we need to write it. And then the other one in red, we have a 0. We have a 0. So this is concave down. And then this is concave up. For the increasing and decreasing, this is going up, going down, and then going up. What is the question asking? The question is asking both increasing on concave up, both increasing and concave up. So that tells me here, this is increasing and concave up. So for increasing and concave up, we have the interval from 1 to positive infinity. What about increasing and concave down? For increasing and concave down, we have that over here. I should use another color. For increasing and concave down, so we have, let's pick this. For increasing and concave down, we have this. So this is increasing but concave down. So we have from negative infinity all the way to negative 1. And then how about from negative 1 to 0? From negative 1 to 0. And how about from 0 to positive 1? From negative 1 to 0, so that is a decreasing and concave down. From 0 to 1, that is also decreasing but concave up. So that's how you do this type of problem. Okay, so if you think that is helpful, give me a like, share, and subscribe. I will definitely see all of you in the next lesson. Signing out.